Most of the artillery in the 19th century had a problem, which was that they used gunpowder for firing, usually black powder and other explosives, resulting in not only a flash but also a large amount of smoke when fired, causing the entire battlefield to be shrouded in smoke during intense combat. In 1883, U.S. Army Captain Zalinsky watched a demonstration of an air gun, which later developed into a larger version of an air cannon. In 1886, Captain Zalinsky founded a company to conduct related research. In the early 1890s, due to health reasons, Captain Zalinsky was unable to work at high intensity, and Rapieff took over his position as chief designer. At that time, their team focused on the research of the 15-inch air cannon, 300 mm caliber, which was named the Rapieff-Zalinski Pneumatic Dynamite guns. The 15-inch air cannon was a very complex and heavy artillery piece. After a series of tests on small-caliber prototypes, the first 15-inch air cannon was installed in New Jersey in 1894, followed by installations in California, South Carolina, and other locations. A set of 15-inch air cannons not only took up a large area, but all the equipment together weighed over 200 tons, making it unsuitable as naval artillery and mainly used as fortress defense cannons. The artillery had a breech-loaded rifled gun barrel. Because the firing pressure was not as high as conventional artillery, the barrel wall thickness could be smaller. To prevent the barrel from bending, a support structure similar to a rifle stock was installed under the front barrel. The artillery was mounted on a rotating carriage, similar to the large coastal defense guns at the time. The artillery could rotate and elevate, and there was a small car on a circular track around the gun mount for ammunition loading. Soldiers would first load the shells onto the car, then align the artillery, open the breech, and adjust the artillery to the loading angle to push the shell into the artillery. The artillery used compressed air to drive the projectile forward, with the compressed air delivered from a pipeline at the breech to the barrel. A separate casing covered the portion from the breech to the rear of the barrel, which was hollow between the outer wall of the barrel and the casing, as part of the compressed air supply equipment. To ensure the ammunition received the most balanced thrust, an automatic pressure control device was installed on the barrel to adjust the intake of compressed air and maintain a pressure of 1,000 pounds per square inch before the projectile left the barrel. Providing enough compressed air for such a large caliber cannon was not simple. The related equipment was placed underground, and multiple large air cylinders were stored in the concrete, connected by a complex pipeline. The pressure here could reach 2,000 pounds per square inch, and the air was passed to the artillery on the surface through a reducing valve to reduce the output pressure. At that time, the production of compressed air was not as convenient as it is now, so a set of double-acting compressors powered by a steam engine was designed to quickly replenish the compressed air needed for firing the cannon. It could achieve 1 shot per minute in the first 10 shots, then decrease to 1 shot every 8 minutes. The artillery used 4 different calibers of ammunition, all with long projectiles. The largest and heaviest was the 381 mm full-size ammunition, and the other 3 were 254 mm, 203 mm, and 152 mm sub-caliber ammunition. Smaller caliber ammunition meant lighter weight and relatively longer range. It is unclear how the sub-caliber ammunition was sealed for firing. However, the firing pressure of the cannon could not be compared with that of conventional artillery, with a maximum range between 1,800 meters and 4,600 meters, depending on the type of ammunition. A test report from 1894 indicated that the flight of the full-size ammunition was unstable, while the flight performance of the 250 mm and 203 mm ammunition was the best. Such a range was no longer an advantage at that time, and with poor accuracy, the advantage of the artillery was its ability to fire relatively quietly. The lower initial velocity caused projectile trajectory bending, allowing the artillery positions to be set lower than protective barriers, attacking targets in a curved trajectory to avoid exposure. Also, because of the lower firing chamber pressure, the projectiles did not need to be filled with as much explosive as conventional shells, resulting in greater striking power. At that time, the ammunition was filled with a low-sensitive explosive composed of nitrocellulose and nitroglycerin, which may be the reason the artillery was called the Dynamite guns. Within a few years of entering the 20th century, the United States successively dismantled and retired its air cannons, as new technological achievements such as smokeless gunpowder were applied to the military field, resulting in the range of rifled guns continually increasing and the elimination of smoke interference. Air cannons with short firing ranges lost their combat value, and retirement became inevitable.